Welcome to the Core Skill Building Collection. In this video, you will learn the basics of the physical and interface n-squared diagrams. The physical n-squared diagram represents the physical connections within a system or system segment. Part of the physical architecture representation set, the physical n-squared diagram represents a high-level structured representation of physical connectivity. It is complemented by the interface n-squared diagram, which presents a high-level view of the logical connectivity between system components. What these diagrams lack in technical detail of various block diagram representations, they deliver in simplicity and clarity. The physical n-squared diagram is available for elements in the component class, as well as any other subclasses of implementation unit. On a physical n-squared diagram, the child components are shown on the main diagonal, forming an n by n matrix of cells. Links that connect a pair of components are shown on the off diagonal. Since the physical n-squared diagram focuses on physical connection as opposed to directionality, there are no arrows shown on the physical n-squared diagram. Instead, the diagram simply represents who is connected to whom. The lack of directionality means that half of the off-diagonal locations are redundant. If A is connected to B, we know that B is connected to A. Rather than showing this information twice, only the upper half of the diagram is used. The lower off-diagonal cells will be empty by definition. Core's n-squared diagrams have been extended to display external links as well. Connections appearing in the right-hand column are links that are either connected to a component not displayed on this diagram, or are not connected to any additional components in the system model. This extension of classic n-squared diagrams provides valuable context, but can be toggled off, as desired in the diagram options. Physical n-squared diagrams are generally higher-level diagrams. A physical n-squared diagram displays only the connections at that level. Links lower in the decomposition are not displayed, nor is the decomposition of components considered when placing a link in a cell. The order of components on an interface n-squared diagram is the sorted order of the children. If desired, you can manually change and manage the order using the Change Node Position command. This can be useful for clustering analysis. The interface n-squared diagram represents the logical connections within a system or system segment. Part of the physical architecture representation set, the interface n-squared diagram presents a high-level structured representation of logical connectivity. Child components are shown on the main diagonal. Interfaces that connect a pair of components are shown on the off diagonal. Similar to the physical n-squared, no directionality is shown on the interface n-squared, because we know if A is joined to B, we know that B must be joined to A. Even though this diagram has been extended to display external interfaces, this particular view has none. This completes the overview of the physical and interface n-squared diagrams. To learn more about using Core, go back to our screencast page and view the rest of the Skill Building Collection.